Hi there. In this video, we'll be working on an example on finding the parts of an ellipse given its equation. So first, let's recall that given an equation of an ellipse with a greater than b, then we know that this is an ellipse oriented horizontally. From the last video, we know that its center is given by the point HK. The semi-major and semi-minor axis is given by the length A and B out here. Then from these two, we can obtain the major and the minor axis, their length, which is just 2 times A and 2 times B. Aside from this, we also know how to get the foci. So the foci is given by h minus c comma k and h plus c comma k. But what is c out here? C out here represents the focal distance, which is given by square root of a squared minus b squared. So we were able to derive this one in a former video in this playlist. So that is how we obtain the foci of an ellipse oriented horizontally. Next, we also learned how to obtain the vertices, which is given by the point h minus a comma k and h plus a comma k. Lastly, we also learned how to obtain the points of the co-vertices. This is given by h comma k minus b and h comma k plus b. And so that is how we obtain the parts of an ellipse from its equation if it is oriented horizontally. So you may take a screenshot of this one for your reference later on. And now, as promised in the last video, I'll also present how we obtain the parts of an ellipse that is oriented vertically. So observe here that A and B switched here since we always remark that A must be greater than B. So in this time, the denominator of y, the one with the variable y, is now larger here. So how do we obtain its parts from the equation? Similarly, the center is given by the point HK. The semi-major and semi-minor axis is given by the length A and B. This time A is the denominator of y and B is the denominator of x. From this, we can also obtain the major and the minor axis, their lengths, which is just 2 times A and 2 times B. So far, so good. Just the same as the first one. How about the foci? The foci is given by the point h comma k minus c and h comma k plus c. Again, c is given by this distance out here, the focal distance, which is also given by c equals square root of a squared minus b. Nothing changes. So take note of this one. Observe that we add and subtract c now in the y component, or the second component out here, since we're along the y-axis. After this, we also know how to obtain the vertices, which is given by h comma k minus a and h comma k plus a. Lastly, the co-vertices is given by the point h minus b comma k and h plus b comma k. These two. Now we add and subtract b along the first component, the first coordinate, which is the x-coordinate, since this one is along the x-axis. So as you can see, the parts for an ellipse that is oriented vertically only changed for the foci, vertices, and co-vertices. For these first 5 parts, it didn't change. So you may take a screenshot of this one as well for your reference and for your own personal use. And as mentioned earlier, we'll try out an example in this video. So without further ado, let's have this example. In here, we're given the equation of an ellipse, which is quantity x minus 1 squared over 16 plus quantity y plus 1 squared over 9 equals 1. So before we solve this, feel free to pause the video so that you may try this first on your own. So good. To start, let's first obtain the center. From the equation, we have 1 out here and plus 1 out here. Take note that plus 1, we can express this as 1y minus negative 1. So clearly, this one is the k, while this one is the h. Or that is, we have h to be equal to 1 and k to be equal to negative 1. So given these two, we can now obtain the center, which is just given by the point h comma k, which is just 1, negative 1. So far, so good. Next is the semi-major and semi-minor axis. But first, is this ellipse oriented vertically or horizontally? Well, we can determine that using the denominators. So by taking the square root of the denominators, we'll have 4 and 3 out here, and clearly, 4 is greater than 3. This means that the denominator of the one with the variable x is larger compared to the one with the variable y. By a previous video, we remarked that this means that the ellipse is oriented horizontally. So what we'll be using in determining these parts is the one that is for the horizontal ellipse, that reference. So you may reference to that one that is mentioned earlier. So continuing, again, when we set a and b, we always take note that a must be larger than b. So between these two, a would be the 4, while 3 would be the b. This means that our semi-major and semi-minor axis is given by the points a equals 4 and b equals 3 out here. And from these two, we can immediately obtain the length of the major and the minor axis. For the major, we have 2 times a, which is just 2 times 4, or simply 8. And for the minor axis, we have 2 times b, which is just 2 times 3, or simply 6. So we now have the lengths of the semi-major, major, semi-minor, and minor axis. Okay, so good. Let's now move on to the foci, the vertices, and the co-vertices. For the foci, recall that this is given by the point h plus minus c comma k. Again, this is in horizontally oriented ellipse. So far we have h and we have k. Our problem is c. But then again, we mentioned that c, or the focal distance, is just given by the square root of a squared minus b squared. So we have a and b, so we just plug that one in. We'll have the square root of 4 squared minus 3 squared. This is equal to the square root of 16 minus 9. 16 minus 9 is just 7. So we have c to be equal to square root of 7. So good. We just plug in h, k, and c out here to obtain the foci, which is 1 plus minus the square root of 7, comma, negative 1. This here represents the foci for this ellipse. So pretty nice. Now for the vertices, recall that this is given by the point, or the points h plus minus a, comma, k. We have h and k, and we have a. Just plug in. So we have 1 plus minus 4, comma, negative 1. And simplifying, we'll have 2 points, which is negative 3, comma, negative 1 if we take the minus out here, and 5, negative 1 if we take the plus out here. So these are the two vertices. Lastly, for the co-vertices, we recall again that the co-vertices is given by the point h, comma, k plus minus b. We have h and k, and b as well. Just plug in. So we'll have 1, comma, negative 1 plus minus 3. This splits into 2, so we'll have 1, negative 4 if we have negative 1 minus 3, and 1, 2 if we have negative 1 plus 3. And so we now obtained the parts of an ellipse, or this ellipse to be exact. We have the center to be given by the point 1, negative 1, the lengths of the semi-major, major, semi-minor, and minor axis to be 4, 8, 3, and 6 respectively. And then the foci, we have 1 plus minus square root of 7, comma, negative 1. The vertices, we have -3, -1, and 5, -1. And lastly, the co-vertices is given by 1, -4, and 1, 2. So as you can see, without even graphing, we were able to obtain the parts of an ellipse just by using the equation. So that was pretty nice. I hope you got that one correctly. And if you want to verify, here is the graph of this ellipse by using it in a software. And we plot the points, the center out here, the foci out here, the vertices out here. As you can see, it clearly matches the definition of these parts as well as the co-vertices out here. So good. So that is the answer for this first example. Actually, this is our only example, but as an exercise, you can work on this one. So as an exercise, we have x minus 2 squared plus y squared over 9 equals 1. So yeah, the process for this one is similar to our example. The only difference is that take note that this equation actually represents an ellipse that is oriented vertically. So this time you'll use the other reference of formulas in determining each part of this ellipse. So yeah, apologies for only having one example since it's quite a lengthy process on how we obtain these parts. But yeah, I hope you had fun in answering the example in this one. So yeah, good. And yeah, feel free to comment down below whatever you want, any comments, suggestions, recommendations, or reactions, or if you have solutions and answers to this exercise, you may comment it down below. And yeah, I hope you enjoyed and learned a lot from this one. So that's it, and that's all for this video.